Okay, this is the question 1 for your response from the 2004 AP Chemistry exam, Form A. It is extremely similar to the 2006 question that I also have worked out on here. Extremely similar, and it shows you just how similar, or maybe how not creative, the AP exam writers are, in that these questions are so similar to each other. And the question 1s typically follow the same pattern going all the way through. So really study these, and you guys are going to do really well on question 1. So we've got silver chromate that we're working with on this one. And they give us, again, the equation, and they also give us the Ksp. And, of course, A is write the equilibrium constant expression. So whenever writing a Ksp, remember, an equilibrium constant expression does not contain solids, and it does not contain liquids. The only thing it contains is aqueous and gases. And so we don't have any gases here, so we really just have the products. And so we're going to take the concentration of silver ion, and we're going to raise it to the second power because it does have a coefficient of 2, and multiply that by the chromate ion. And because it does not have a coefficient, or you could say it has a coefficient of 1, then we're also going to raise it to the power of 1. So there's A. Short, sweet, and to the point. B, calculate the concentration of the silver ion in a saturated solution of silver chromate. So the way that you do this, we know the value of Ksp. We know that as silver chromate ionizes, you're going to get, let's say we set up a rice table. So B. R-I-C-E. Do not make fun of the way that I say I's. I know you're all thinking it right now. Nah, it's all right if you make fun. I make fun of myself. Just getting the equation written here. Okay, so let's just call our beginning concentration of the silver chromate. We can just call it I. It doesn't really matter what it is, whatever it is that's given to us. And of course, our starting concentration of the ions, they're both going to be 0. Well, the change is going to be, this is going to go down by a value of x. This will go up by a value of 2x, because whatever this goes down by, it's a 1-to-2 ratio. So this will go up by some value that's double whatever this goes down by. And because this one is a 1-to-1 mole ratio, this one's just going to go up by x. Well, in our Ksp, we don't really care about the silver chromate because it's a solid, it's not included. So our silver ion will have some value of 2x, and our chromate ion will have some value of x, which we can then take back and plug into this equation. So Ksp, which we know is 2.6 times 10 to the negative 12, is going to be equal to, plug in the 2x for the silver ion concentration, so that's going to be 2x squared. Plug in the x for the chromate, so we're going to multiply that by x. Well, looking at this, you see that this is going to be equal to 2x squared is really just 4x squared times x is going to give us 4x cubed. So divide both sides by 4, take the cubed root, you end up with x equals, I went ahead and multiplied it by 2. X equals, sorry, not prepared. Let's see. 2.6 times 10 to the negative 12 divided by 4. So x cubed, I'll go ahead and write this whole thing out, is 6.5 times 10 to the negative 13. Well, now take the cubed root of each one, and you're going to get that x equals 8.7 times 10 to the negative 5. Well, silver is not x, it's 2x. And so to find the silver concentration, which is what the question is asking for, we actually have to take this and multiply it by 2. So the concentration of the silver ion is going to be 8.7 times 10 to the negative 5 times 2, which works out to 1.7 times 10 to the negative 4 molar. So that's B. Yes, it took a while, but it's, you know, it's not that hard once you kind of start working it out. It just takes a while. And typically for number one question, you have between 15 and 20 minutes to work it out. So you've got quite a bit of time to work this out. All right, calculate the maximum mass in grams of silver chromate that can dissolve in 100 mils of water at 25 degrees Celsius. Well, right here, we figured out the concentration of the chromate ion, which would be the concentration of the silver chromate that will dissolve. So we can start actually right here with this number. I'm going to write down here, and I'll switch up colors just to keep things interesting. So we have 8.7 times 10 to the negative 5 moles of silver chromate that will ionize per 1 liter of solution. That's what this number right here is saying. Remember that X stood for how much chromate ion will be floating around in solution, and because it's a 1-to-1 ratio, however much chromate ion is floating around in solution, that's how much of the silver chromate has actually ionized. So now the other piece of information that I was given was the volume of my solution, and then the question wants to know calculate the mass in grams. So I basically need to cancel out moles and liters and be left with grams. Well, I can cancel out my liters with my volume right here. So since I have liters on bottom, I need my liters to be on top. So I'm going to go ahead and convert this into liters by going 1, 2, 3. So 100 milliliters is 0.100 liters. So now my liters cancel out. And then to get rid of moles, you guys know you use the molar mass. And the molar mass of silver chromate is 1 mole of silver chromate has a mass of 331.74 grams. You actually get a point for this on this question for simply indicating that you knew you needed molar mass and for writing it down. So even if you couldn't figure this out, hopefully you can recognize, oh, mass, I'm going to have moles up here, just get this wrote down. We can just write the molar masses down of everything. So, how to put this into here so that everything cancels out right? Well, I got moles of silver chromate on top. So I'm actually going to put my 1 mole of silver chromate on the bottom. So that way my moles cancel out, which means that my grams, my 331.74 grams has to go on top. And it is okay that what you're canceling with, what you're simplifying with, is like separated by a block. That's fine. As long as one's on top and one's on bottom, it all works out. So we can cancel stuff out. I'll switch colors yet again. And our moles of silver chromate are gone. Our liters are gone. And we are left with grams of silver chromate, which is exactly what the question asked for. So you work this out, calculate it, and you end up with 0.0028 grams of silver chromate. Whoa, forgot the R, my bad. So that's C. Now I'm going to move this out of the way so I can get things cleaned up and move on to D. It's going to come back, I promise, don't worry. So on D, it says a 1 mole sample of solid silver nitrate is added to a 1 liter saturated solution of silver chromate, assuming no volume change. What happens to the chromate ion? Well, just like in the 2006 question video, you can explain this using either Q or Le Chatelier's. I personally prefer Le Chatelier's, so that's what I'm going to go with. So silver nitrate is going to completely ionize because it is soluble into the silver ion and a nitrate ion. Well, we don't have nitrate anywhere in this solution, so we don't really care what he's doing. But it is going to increase our silver ion concentration. And Le Chatelier says that you shift away from whatever was added to try to use up what was added. So our reaction is going to shift to the left. And the question wants to know, does the chromate concentration increase, decrease, remain the same? Well, since chromate is on the right, the chromate concentration is going to go down as the reaction shifts back towards reactant to try to use up that excess silver that was added. So that's that one. And if you want to see the Q explanation, watch the 2006 video. It works out the exact same way, just using a different compound. So our next silver compound is silver phosphate, and they want to know, they give us the equilibrium expression, so now they want the balanced equation, and this is what you guys will see. Either they're going to give you the balanced equation and then ask for the equilibrium constant expression, or they'll give you the equilibrium constant expression and ask for the balanced equation. So getting the balanced equation couldn't be simpler. Here is your solid. So you would have Ag3PO4 solid is going to partially ionize, and then here are your reactants, and remember that your superscripts tell you the coefficients. So we're going to get 3 silver ions that will be aqueous and 1 phosphate ion that will also be aqueous. And then they want to know the value of Ksp for silver phosphate. Well, they say in a saturated solution, the concentration of silver is 5.3 times 10 to the negative 5. So that number we are going to plug in right there. Well, in this reaction, I'm going to write over the top of the question for a second. Well, sorry. So the initial would just be some value. The initial on these guys is going to be 0. Well, we know that at the equilibrium concentration, we're going to have 5.3 times 10 to the negative 5 on the silver. And we know that the silver phosphate is going to, that means this guy went up by 5.3 times 10 to the negative 5. Well, we know that it is a 1 to 3 ratio. So for every 3 silver ions you get, you're only going to get 1 phosphate. So to figure out the change in phosphate, we actually need to take this number and divide it by 3. And so 5.3 times 10 to the negative 5 divided by 3 is 1.8 times 10 to the negative 5. So that's going to be the equilibrium concentration of the phosphate, which we can then take and plug in to right here. So to calculate Ksp, that's going to be the silver concentration, 5.3 times 10 to the negative 5. Oh, we got stuck again. Every once in a while, this pen messes up and it drives me batty. And then we're going to actually raise that to the 3rd power, and then we take the phosphate ion concentration, 1.8 times 10 to the negative 5, and that's just raised to the single power because it's got a coefficient of 1, and you plug that into your nifty little calculator, and you get 2.7 times 10 to the negative 18, so a really tiny number. So silver phosphate is very, very, very not very soluble. And then on G, a 1 liter sample of saturated, I'm going to switch colors again, of saturated silver phosphate solution is allowed to evaporate to a final volume of 500 milliliters. What is the silver ion concentration in the remaining solution? And justify your answer. Okay, this is very similar to, I believe it was D on the 2006 question. Remember what we said about molarity, concentration. Molarity is moles per liter. It doesn't matter how many liters you have, molarity is going to stay the same. So if we start out with a 1 liter sample and let it evaporate to 500 milliliters, the molarity is going to stay the same because molarity is not affected by volume. Now, I know you're thinking, hey, wait a minute, no. The volume was cut in half, therefore the molarity has to have doubled. But what you forget about is if you have a beaker and it's filled with a certain volume of the saturated silver phosphate solution, which means that we're going to have some silver phosphate solid down here in the bottom with a few ions floating in the solution. Well, as the liquid evaporates off, what's going to happen is you're going to have some of these ions that come together and settle out of solution. And so as the liquid evaporates off, you're going to have more solid build up in here, but the concentration of the ions in the solution is going to stay the same because based on Ksp, it has to. So the amount of solid built up in the bottom would probably increase as that liquid water evaporated away, but the overall concentration of the ions is going to stay the same. So that's all I have. If you guys have any questions, you know how to get a hold of me.